And the root word for dissolving is dissolve, which is the ability to dissolve, ability to do this.
Wait, hold on.
The next two clicks on the thing have that. They're not quite in order. There. All right. Okay, the solute needs to be soluble. We're starting to use vocab words in the definition of other vocab words. This makes things tougher to learn, which is why you got to use the flashcards, why you got to pay attention and write out, take notes and stuff, okay? Because it all connects and it's really confusing that way. The solute has to be able to dissolve. The solute needs to be able to dissolve. Do all powders dissolve? No. If I take salt and I put it in water, it dissolves. It is soluble. It'll break apart into little atom-sized pieces. If I take sand and mix it with water, is the sand soluble? Will it break apart into little atom-sized pieces? What if I heat it up? Still no. What if I stir? Still no. What if I try to make the sand into smaller chunks by grinding it up and then put the smaller chunks in? Still no. Alright? Sand is what's called insoluble. It's a powder that will not dissolve in water. Are there other solvents that might dissolve sand?
Yeah.
Yes. I might be able to get sand to dissolve in acid. Okay? But soluble is when these two things come together, they will either break into atom-sized bits, or if it's insoluble, it won't break into atom-sized bits. Okay? So soluble means it's able to dissolve, and insoluble means that it can't. So if I have sand and water, and it's insoluble, we have soluble and insoluble. If it's insoluble, then that might make it a suspension instead of a solution. Everybody there? Okay. All right, and I want you to notice something before I go to this slide here. Look at all of the words that we have for solution so far. What three letters is in every single one of them?
S-O-L.
S-O-L is the root word. That means that word is about a solution. S-O-L is the root word. There's a bunch of these. I mean, there's already 7 S-O-L words. And there's more before the section is over. You have to study these S-O-L words. Otherwise, you are going to end up S-O-L. Shucks out of luck. All right? You want to make sure that you study your S-O-L words very, very carefully. I don't want you to be SOL on the test. All right? Where am I? I'm right here. Next. Now we talk about solutions, and usually we're talking about a powder and a liquid. But that's not all of what solutions are. So there's a special kind of solution where you take two solids and you heat them up to the point where they're melting, and then you dissolve them in each other and cool it back down again to a solid. It's a special setup. This setup creates something called an alloy. Steel is an alloy. Brass is an alloy. That is why you won't find steel on the periodic table. Because steel is a mixture. It's a combination of iron and chromium and carbon. They heat it all up till it's melting, and then it all dissolves in each other, and then they cool it back down again to make steel. All right? Another example is, this is an alloy that looks like mercury, but it's really indium, gallium, and tin. They use it as special effects stuff, because mercury is a little bit more hazardous, so they try to use an alloy that looks kind of similar.
Wait, does mercury burn your skin?
It does not burn your skin. Mercury doesn't actually damage your skin at all. What happens is that mercury will evaporate. It's in mercury vapors. And then that gets into your lungs, and that causes heavy metal poisoning.
Isn't it like when in like China when they make shark fin soup, don't they have to be really conscious of that? Because
I have no idea. I really don't know much about shark fin soup. Okay. Now, concentration, I am not teaching this year. It is not going to be on the standard test. Concentration will be on the premier test, so that's something that you'll have to teach yourself using the book if you choose to do the premier test. This is another reason why I am not recommending the premier test for this particular unit, because of the difficulty of this particular unit. Okay? All right. I want you to think about Kool-Aid. Has everybody here made Kool-Aid or had Kool-Aid at one point in their life? All right. If you have Kool-Aid, I want you to imagine, what if somebody took twice the amount of powder that they're supposed to put in the Kool-Aid and put that in the Kool-Aid? Double the powder. Okay? How do you describe the flavor? What do you say?
really sweet.
You say it's strong, typically. You might say really sweet, but usually the word that comes to mind in the average junior high vocabulary is strong. This Kool-Aid is really strong. Does that make sense? Strong is basically a synonym for concentrated. All right? It has lots of solute in it. Concentrated, lots of solute. Now think about it if your Kool-Aid is made with half the recommended powder. Half the recommended powder. What usual word do you use to describe that?
Dull.
Dull is not what I usually hear people say. Weak. Weak is a little bit more common. Okay? Weak is more common. So, a dilute dissolution would be a weak solution, meaning not very much. Solute. So now we've got two more words to add to our list of solution words. Concentrated and dilute. Oh, forgot to write alloy. Yeah.
Well, like when you say dilute, like I think of, like my mom used to dilute like juices.
Right. If you ever go to the grocery store, you can get orange juice from concentrate at the grocery store. You ever go to the freezer section and see the orange juice in little cans?
Mm-hmm.
That's concentrated orange juice. What that means is that they've dissolved the orange juice stuff in as little amount of water as they can. So the orange juice is got maybe 1/10 the amount of water that it's supposed to have for normal flavor.
Ugh.
So then they sell you the can of orange juice, and then you go home and you mix that orange juice with water to dilute it down back to normal.
That'd be great.
Why? Because we sweet.
Does that make sense? I'm using a lot of words in there, using a lot of vocab words. Are you following along all right? Okay. All right. Next two. Saturated and unsaturated. Now, the second I say saturated and unsaturated, the first thing that students typically tell me is they ask about saturated fats they learned about in health class. Okay? And saturated fats do use that word correctly, but it's another science definition. I want you to think for a moment about what is a non-sciencey definition for saturated. Where do you hear the word saturated used in regular junior high life? Yeah.
Like if someone sprays you with a hose and your clothes will become saturated.
Okay, someone sprays you with the hose, your clothes become so wet that they can't get any wetter, so then your clothes become saturated. Somebody is watering the lawn. They water the lawn so much that there's puddles on the ground because the ground can't absorb any more water. That's what saturated means. You've put in so much you can't put in any more. That's what it means in science too. You've put in so much you can't put in any more. All right? So a saturated solution. Now I know here is our salt water. All of the salt has dissolved in this salt water. So right now this salt water is unsaturated. That means there's still room in here. I could get more salt to dissolve. So it's unsaturated. But when I put more salt in here, eventually it doesn't matter how much I shake or how much I heat it up, there is always going to be a pile of salt on the bottom. Okay? Because no more salt is going to dissolve in here. It's hit its maximum ability to break apart into tiny little bits. And so it leaves a big old pile. I know it's white on white. Can you see it? It leaves a big old pile of salt on the bottom. This means that this water has become saturated with salt and no more salt is going to dissolve. It is a saturated solution. All right?
I have a question about like since the ocean's salt water,
Yes.
is there a high amount, like if you took a glass of salt water from the ocean, Do you know, is there a high amount of salt in the, like, ocean?
High?
In a cup of it.
High is not a specific word.
A lot of salt in, like...
A lot is not specific either. I don't know what high and a lot mean. I do know that you can find the answer to your question on Google. If you like say how many grams of salt are in 1 cup of salt water, that's a number that can be found if you search for it on the internet. It is not a number that I have memorized ready to share with you. Does that make sense?
Yeah.
That's like, I don't have like a billion random facts just tucked in there.
Yeah.
So, but it is a fact. It is something that's findable. Okay? Yeah.
Like every day, you could do that with like tea. By accident, put too much sugar in it.
Oh yeah. Put too much sugar in your tea? Absolutely. You can do that with Kool-Aid, but there's still granules of Kool-Aid stuck on the bottom of the thing. Yeah, that's you've made a saturated solution. All right. Solubility. Solubility is a specific number. It is the amount that dissolves in 100 milliliters of water. This is really close to what Cody was asking about, the solubility of salt in ocean water. It is how much does it take to get to a saturated solution? Okay? How much does it take to get to a saturated solution? There is a graph on the last page of the chapter that is specifically about solubility. I will talk about solubility some more tomorrow, in addition to talking about colloids tomorrow. This solubility graph that's on the last page of the chapter is on the test. That actual graph is on the test with questions about it. So you want to make sure that you understand that graph. So we'll spend a little bit of time talking about it tomorrow. That's it for today, folks. Yeah?
3.2% of salt is in 1 gallon of ocean water.
So how many grams is that?
3.2.
3.2 grams in a gallon?
Yep.
All right. Told you it was findable.